Okay, I want to do some examples using the multiplication principle of equality. I'm going to show you like the proper way to do it, but then I'm also going to talk about kind of some shortcuts that you can, utilize, make it go a little bit quicker. Let's say that we have a problem like 3 times x, or 3 times a number equals 15. Okay, so basically our goal here is to find the value of the x. So we want that x variable to be all by itself on one side of the equal sign and all the numbers to be on the other side. Now we're going to go ahead and use the multiplication principle to do that. And basically, because we're multiplying by a whole number, we're going to actually multiply by the inverse of that whole number, which would be 1/3. So if we take 1/3 and multiply it to 3x, or you could put a 1 under that, because we're multiplying by 1/3, what we're doing is we're basically going to be able to cancel here. Okay, 3 goes into 3 once, and so that's going to leave you with x over 1, or just x. But remember, when you're also multiplying or doing any operation on one side, you want to do the same operation to the other side. So 15 times 1/3, or 15 over 1 times 1/3, really what we're doing is we're dividing 15 divided by 3, or you could just reduce 3 goes into 3 once, goes into 15 5 times, and so we get x equals 5. Now x equals 5 is going to be the solution for this particular equation. Now if this equation changed in any way, 5 would not necessarily be the solution. Okay? Now what we always want to do, in addition to solving for the variable, is to plug in that value for x and check to make sure you come up with something true. So for instance, 3 times x, or 3 times 5, does that in fact give you 15? And in this case it does. 15 will equal 15, and since that is true, x equals 5 is the solution. Okay, let's do a couple more, and then we'll come back to this problem, and I'll show you a shortcut way of doing it. Let's say we have, use a different pen. Negative 5x equals 45. Negative 5x equals 45. This problem is very similar to the last one. We've got a number times a variable equals another number. And in that other case, we multiplied by the inverse. So we're going to do the same thing here. We're going to multiply by the inverse of negative 5, and that will be negative 1/5. Okay, so we're going to multiply that to negative 5x. I'm going to write that as a fraction, negative 5x over 1, and then have my 45 times negative 1/5. I'll put a 1 under there. Okay, now we're just going to go ahead and cancel 5, and this 5 cancels. And if you think of the negative 5, so that negatives with that. So negative times the negative is a positive. We're left with x over 1, or x. 5 goes into 45 9 times, goes in once. Now we've got this negative here, or you could have, it didn't matter where this negative was, you could have had at negative 5, 45 divided by negative 5. Instead I left the negative off, but we want to consider it here. 9 times negative 1 is going to be negative 9. Now if you're not sure about the negative sign, what you want to do is plug in this value into the original equation, and that will for sure tell you if that negative should be there or not. So let's go ahead and do that. We've got negative 5 times negative 9. I know that when I multiply two negatives, I'm going to get a positive. And since 45 here is a positive number, that's going to be true. So 45 does equal 45. True. Now, if you weren't sure about that negative and you just plugged in a positive, you would know that a -5 and a +9 would give you a -45. And notice that is not the same thing as 45. So that's not true. So checking is always a good way to make sure you have the right number of the solution, but also the right sign. Now I want to go back to that original problem that we did. Let me grab that real quick. So right here, I was telling you, in these last two problems, we were multiplying by the inverse. So if you have a whole number, the inverse is basically, you're flipping. So for instance, if this is 3, as a fraction, that's 3 over 1, and the inverse would be 1 over 3. Okay, so this is the inverse of 3, written as a fraction. Now, if you look over here, it looks like we're reducing, and we are. 15 and 3 can be reduced, or 3 goes into 15 5 times. But really what we're doing is we're dividing. We're dividing 15 by 3. If we didn't reduce, if we just multiplied straight across, we'd get 15 divided by 3. So another way to look at these problems is that if you have 3 times a number equals a number, instead of writing it, or instead of multiplying by the inverse or multiplying by 1/3, you could just divide by 3. So I'm going to rewrite it. So if I go 3x equals 15, I could just divide by 3, because this is 3 times a number. So I'm going to do the opposite operation. I'm going to divide by 3, and again, you want to make sure you keep the balance. Do the same thing on the other side. These are going to cancel, and we're left with x, and then the value of 15 divided by 3 is going to give you 5. Now, we're going to get the same solution, okay? We get the same solution. Sometimes people find this way a little bit easier, and because you're going to get the same solution, it's going to work out fine. Just note that, when you're multiplying, so when you have 3 times 1/3, that's really the same thing as 3 divided by 3. Okay? You're going to get the same answer, because this becomes 3 over 1 times 1/3. These cancel. You're just going to get 1. And if you divide 3 by 3, you're going to get 1. So it's just different ways of writing it out, but you're going to get the same answer. All right, I'm going to move on to some other type of problems that you're likely going to see. And I know in class we covered a few of them. We didn't have time to do them all. All right, let's say we have the variable up on top of a fraction set up. Okay, so you want to think of it in terms of what operation is going on here. This is really 3 divided by 10, or excuse me, not 3, x divided by 10. So x divided by 10. So in the multiplication principle of equality, we're going to multiply a number to this setup here so that we can isolate x. We want x all by itself. We want to get rid of that 10. So this is really 1/10. That x over 10 is also the same thing as 1/10 x. So the inverse of 1/10 is going to be 10. So let's multiply by 10. So we're going to go 10, or 10 over 1, because this looks like a fraction, times x over 10. And then do the same thing, 7 times 10. Okay? Now, let's reduce. These cancel. 10 and 10 goes in one time each. We've got x over 1, which is the same thing as x, equals 7 times 10 is 70. That's going to be our solution. Let's check our work just to make sure. So we're going to plug in 70 for x, so it's going to look like this, which is basically saying 70 divided by 10. Does that equal 7? Well, if I can cancel that way, and 7 divided by 1 is going to give me 7. So 7 equals 7. This is true, so this is the solution. All right, let's do some more. I have another scenario here that you might see. That looks a little different than that last one, but it kind of looks like a fraction. Let's say we have 1/2 x equals 3/5. 1/2 times x equals 3/5. So remember that multiplication principle. We're going to multiply the inverse. So the inverse of 1/2 is 2, or 2 over 1. Okay, 2 over 1. So that's what we're going to multiply to both sides. We're going to say 2 over 1 times 1/2 x equals 3/5 times 2 over 1. And I'm keeping it in a fraction on this side mainly because on the right side it's in fraction form, so it's just going to be easier to work with. These 2's are going to cancel. I'm left with 1x, or just plain old x. Let's see if we can reduce. Doesn't look like we can, so we're just going to multiply across. We get 3 times 2 is 6, 5 times 1 is 5. We can change that to a mixed number. It's going to be 1 and 1/5. This is the solution, but I recommend we check. So I'm going to go ahead and check. I'm going to use this fraction instead of this one, because when I'm multiplying fractions, I like to go ahead and change the mixed numbers to improper fractions. So I'm just going to go ahead and use this version of the answer. So it's going to look like this: 1/2 times 6/5 equals 3/5. And let's see if that is true. I can reduce. 2 goes into 6 3 times. 2 goes into 2 once. 1 times 3 is 3. 1 times 5 is 5. Hey, that's the same thing over here. This is true. So I feel pretty confident that x equals 6/5 or x equals 1 and 1/5 is the solution for this equation. Okay. Well, let me see if I have any others on here. There's one other problem I want to show you. Here we have 2x over 3 equals 10. 2 times a number divided by 3 equals 10. And this, actually what we're going to do here is we're going to do the multiplication principle 2 times. Okay? And let's look at all the operations that are going on here. This is 2 times a number, so we got multiplication, and we also have, we're dividing by 3. Now whenever you've got this fraction set up, or this division set up with the line going across, oops, it's a good idea to eliminate this by getting rid of whatever's in this position. So because this is dividing by 3, we're going to multiply by the inverse of 3. Now, there is a couple ways. I'm going to show you one way, and I'll show you another way. The second way actually might be faster, but let's go ahead and look at this one way, if we break it down. So this is really like a third, or in this case 2/3. So if I multiply by 3, 2/3 or 2x over 3 equals 10 times 3. We can cancel those 3's, and then we're left with 2x equals 30, because 10 times 3 is 30. Okay. Now, this is 2 times a number equals 30, and you probably can think of the answer. It's going to be 15. But, and you can think, well, if I multiply the inverse of 2, I'm really multiplying by 1/2. Or you can think of it as dividing by 2. And then you get x equals 15. Let me show you another way. And you might have thought of it when I was doing this business here. I'm going to rewrite it. So say we have 2x over 3 equals 10. Now we could just focus on these numbers here. What's the inverse of 2/3? Well, it's 3/2. So if I multiply by 3/2 on both sides, we should get the same answer. Notice these 3's are going to cancel and these 2's are going to cancel, leaving me just x. And now I can work this side. 2 goes into 10 5 times, goes in once here. 5 times 3 is 15. 15 over 1 is 15. Notice you get the same answer. Okay, same answer. This way is probably a much more efficient way, because you're basically taking care of both the top and the bottom numbers. But I just wanted to show you if you wanted to just piecemeal it together, you could. Now let's check the work. One more piece of paper here. So if our original problem was 2x over 3 equals 10, and we said x was 15, we're going to go 2 times 15 divided by 3 equals 10. 2 times 15 is 30. 30 divided by 3. Well, 30 divided by 3 is 10, because 10 times 3 is 30. So that is true. So I feel pretty confident that x, in this case, is 15. That's my solution. And we're going to use that word solution when we talk about solving for variables. So practice using it. And practice using, the multiplication property or principle of equality, whether you are multiplying by an inverse, or if you're using the division, that's fine. You're going to get the same answer. So, like always, if you have questions, ask in class. We'll do more examples in our next lesson.